in this example, we look at how we apply the inverse normal distribution function. So here we're going to be given a probability, and then we can use our calculator to find a value of a such that, for instance, the probability of x being less than a is equal to that given probability. This function is usually called the inverse normal distribution function on our calculator, as we are working out the inverse of the normal calculation. So here we're given the probability and we're working backwards. So let's take a look at this example here. It says find correct to 2 decimal places the value of a such that probability of x less than or a is equal to 0.75. We're given the normal distribution here. It has a mean of 20 and a standard deviation of 3. So as always, we start off with our normal curve. And we put in the mean value here, which is 20. And let's mark where a is going to be. Now remember, probability of x less than a is 0.75. So it's unlikely to be on this side, because less than that value is not 0.75, because the total area is 1, and we know halfway it's 0.5, so it's unlikely to be that. So a is likely to be on the right-hand side. It's on the right-hand side somewhere. We don't know exactly where, but that's fine. We'll label that as a. And x, probability of x less than a, i.e. everything to the left-hand side of it, this area here, is equal to 0.75. So I'll just make a note here. This area is 0.75. So here we want to use our inverse normal function on the calculator. So go to our calculator and we want to choose inverse normal. And here we are given, after we choose inverse normal, we are given a few options. So inverse normal on our calculator, and the options that we have for the input is the area. Now the area is obviously the probability that we have. And we also have an input for sigma, and we have an input for mu. Now with the inverse normal, it only recognizes area as being everything to the left-hand side of it. So it only does cumulative from the left-hand side up to and including a number. So it will only work out left-hand side areas, i.e. if you think about CD, it will only work out this area. It will not work out the right-hand side area. So the area that we must input must be the left-hand side of the A value, whatever we're trying to work out. So in this case, our area is on the left-hand side of the A value, so I can go and put in the 0.75, which will be fine. The standard deviation here is 3, and the mean is 20. So putting in these values in our calculator will then give us and put in an answer of 22.02 here. So this is giving us the value of A here. This is the output. A is equal to 22.02 to 2 decimal places. Now we can go and take a look at part B, which is slightly different because it's asking us to work out the value of A for which the probability of x being greater than a is 0.4. So start with our normal curve, put in the mean value here. We want the area to the right-hand side of a to be 0.4. Now, as this area is split into half, and we know that everything in one half is 0.5, therefore, if we want an area greater than a to be 0.4, a must be again on this side here, and we're after this area. Now, remember, when we use the inverse normal function on our calculator, the area that we can input for the calculator here will only be the left-hand side. The calculator will only input this left-hand side area, and so this is what we must work out first before we can go to our calculator. If we know this area, which is given to us, is 0.4, and we know the total area under the curve is 1, then we can work this area out relatively easily. It is 1 minus 0.4, which is equal to 0.6. So we can then go and use this left-hand side area, since the calculator only does the left area to the left of a value. So calculator input here is 0.6, sigma is equal to 3, mu is equal to 23. And when we go and do that and put those values into our calculator, it gives us a value for A in this case of 20.76. Okay. And lastly, we want to work out the value of A such that the probability of X greater than 16 and less than A is 0.3. Probability of X greater than 16 and less than A is equal to 0.3. So again, start by drawing our normal curve. Put in our mean value at the center. And we want greater than 16. So 16 is on this left-hand side. And less than A to be 0.3. Now, we're not sure where A is. It could be to the left of 20. It could be to the right of 20. Not exactly sure. Okay. Doesn't matter where I put it here for the time being. I'm just going to assume that it's actually on the left-hand side. It might not be, but it doesn't really matter. I'm going to put that down. Now, they've given us in the question that this probability here, the probability, this area here is 0.3. Now remember, our calculator does not work out for inverse. It does not work out, use this area as the input. It does not use the right-hand side area as the input. It will only use the left-hand side area. So how can we work this out? Well, we need to first of all work out what this area here is to the left of 16, because we can work this out using our binomial CD function, not the inverse one, the normal CD function. We can use our normal CD function to work this out. So let's work out what this area is. How do we work this out? We're going to go and use our normal CD function. And for this normal CD function, if we go to our calculator and go to the normal CD function, remember we have inputs of lower value. So put in a very large negative number. Let's use -1000. An upper value here would be 16, since that's where we're trying to get up to. And then we have our sigma value, which is given to us in the question, which is 3, and our mean, which is 20. And this will then give us a probability of 0.09121. So this probability here is 0.0921. So this gives us a probability of 0.09121. So the area that we have here to the left-hand side is 0.09121. So now we can go and use our inverse normal function on the calculator, because we have the area to the left of A. What is the area to the left of A? Well, the area to the left of A is a combination, well, it's adding the 0.3, which is that middle blue area, plus the 0.09121, which is to the left of the 16. That is the total area to the left of A. So we can go and use our inverse normal now on our calculator. And remember, for the inverse normal, the inputs that we put is area to the left of a particular value, and the area that we're going to use is 0.3 added with 0.09121. So let's work out what that is first. And that gives us a value of 0.39121. So this will be the value that we put into our calculator, 0.39121. And our sigma is still 3. and our mu is still 20. And then putting in these values into our calculator gets us a value for A here, which is equal to 20.76. So that's the value of the A necessary to give us an area to the left of A of 0.39121.